Hey guys, ready for another video? In this video we are going to look at the chair conformer of cyclohexane. Now you should know that cyclohexane is mostly found in three conformations. One is the chair, which is the most stable one. Then you have the boat conformation, and the final one is the twist boat conformation. There are other conformers possible apart from these, but they are not as stable. And the most stable one of these is the chair conformer. So we are going to learn how to draw the chair conformation. And if you are wondering what that looks like, it is this diagram present here. This is the chair conformer of cyclohexane. I am going to show you how you can draw this diagram in the easiest possible way, and then we are going to look at a flipped kind of chair that is opposite of this diagram as shown. So let's get started and let's see how to draw the chair conformer for cyclohexane. Right, so I want you to start with drawing a flat V like this. Okay, in the second step, what you are going to do is you take this first line and draw a line parallel to that below it. So far so good. Now the next step involves drawing two more parallel lines. One line will start from this point here, and the second line will start from here. So look carefully what I do. I will draw the first line towards the bottom and the second line towards the top, and these 2 points will match here. We can extend this a little. Now we have to close this diagram, and so I join these two remaining points. And that, friends, is the chair form for cyclohexane. I am going to do it once again for you. First you draw a flat V. Then you draw a line parallel to the first line but below it. Then draw two parallel lines like that, and then close the figure. Now, if you start counting, you will see that there are 1, 2, 3, 4, 5 and 6 carbon atoms. Each of these carbon atoms has 2 bonds, so the remaining 2 bonds are formed with hydrogen atoms, and so the formula is C6H12. Easy, right? This is how you draw the chair conformer for cyclohexane. But let's think about it a little more. Why do I need to draw a line parallel to the first line? I could have done it for the second line as well. Let's see what happens if I do that. Okay, so start by drawing a flat V like that. But this time you are going to draw a line parallel to the second line. So we have our next line like this, and then you are going to draw two parallel lines. One is going to this side and the other one is going to match over here, and then close the figure. This is also a chair form for cyclohexane, but how is it different from the first one? Well, focus on these two carbon atoms. In the first structure, the carbon atom on the right is going upwards, whereas in the second structure it is going downwards. In the second structure, the first carbon atom here is going upwards, but in the first structure it is downwards, right? So these two structures both represent the chair conformer for cyclohexane. The process by which I converted the first structure into the second one, or vice versa, is what we call a ring flip. So we flipped the ring, right? Let's see what we mean by that. I will draw these two structures side by side and you can compare for yourself. The first structure is obtained like this. Okay, and the second structure is obtained in this fashion. Okay, so if you place a mirror before the first structure, a plane mirror, then you can see that the mirror image of this structure 1 will resemble structure 2. So what does a ring flip actually do? It converts a chair conformer into its mirror image. That's it. It converts a chair conformer into its mirror image. That's it. We are going to explore more of this in the coming videos when we have talked about the axial and the equatorial positions, and then what effect a ring flip does on those positions. But this is enough for this video. See you in the next one, and if you liked the content, please subscribe because more educational videos are coming for you very soon. See ya.